Hello, welcome to today's session called Demystifying DevSecOps, presented by Sonar and Snyk. Thank you for joining us today. We have a very interactive discussion with a few slides and a lot of opportunity to ask questions. There might be a poll, and we do encourage people to share their questions that we will try to work into the discussion, and we won't save it till the end necessarily. Just to note that this is also being recorded and will be sent to everyone who registered and anyone who attends today as well. So without further ado, I will introduce Simon Maple, who heads up developer advocacy from Snyk, as well as Nicolas Bontoux from Sonar, who heads up product marketing. And they will take us through the discussion, and there might even be a demo. So enjoy today's session.
Thank you very much, Sarah, and we'll start the session and we will introduce ourselves very first. So why don't I kick us off? There we go. So my name is Simon Maple. As mentioned, I'm a developer advocate here at Snyk, and I started my life way back when as a developer advocate, as a software developer at IBM, in fact, and I did around 12 years of development on WebSphere application server. And I've been a developer advocate for probably about the last 7 or 8 years, maybe a little bit more. So yeah, I've kind of tried to keep my fingers in code, but struggling these days. Where do I live? Well, I'm in the UK right now. You can see actually right now I'm that little blue dot on the far west coast of the UK. Sorry, far east coast of the UK. But I live a little bit southwest of London normally in a little place called Basingstoke. I work for Snyk, a company which really aims in allowing developers and others throughout the security, the development lifecycle to use open source security securely in their applications. And we go about that by allowing developers to find and fix those vulnerabilities in applications and containers to make the world a safer and better place. And with me today is Nicolas. Welcome, Nicolas.
Thank you, Simon, and here I am. And I do have this commentary with you to be a software developer back in the days. First of all, so good morning or good evening or good afternoon, wherever you are. So I'm Nicolas from Sonar. Like I said, also come from a software engineering background. In fact, at the time I was for Cisco, doing a little bit of Python, and then starting to look at continuous integration, continuous deployment, helping the team set up the tooling and the frameworks there, and quickly getting excited about helping even more people. So I joined Sonar as a support engineer, in fact, helping community, helping customers too, but really kind of any user to adopt the best practices. And at Sonar we're mostly about code quality, code security. So that's where I started to be, pretty high on those topics, and going from not just the customers and community to really do some product marketing and share it with the rest of the community and with you guys today. I'm actually based in Geneva. You can see it's very close to the French border, so I actually live on the other side of the border. But Sonar has a couple of offices around the world, and our headquarters are in Geneva right now.
At Sonar, it's probably better where you are than where I am today.
A little bit, but the snow is rapidly going to come.
Really?
On the Sonar side, so basically, and you can go to the next slide, Simon. We've all been about code quality and security for quite a while now. In fact, the company, we celebrated our 10 years old last year with some big cakes and birthday. Our mission is pretty simple: helping the world, writing better and safer code. Most of you, I suppose, might know us for Sonar Cube, which is a historical product, even called Sonar back in the days, for those of you that use it since a long time. We kind of grew this towards the same mission of developers code in the IDE, and so we provided IDE tooling. There's been a shift to online services and online pipelines, and we now have Sonar Cloud. But ultimately, the mission remains the same, and it's all about code quality and code security. And I think one of the reasons exactly why we wanted to chat today, I can say, is not because we want to talk about a specific feature or specific integration, Simon, but it's more about friendship between the companies, right?
Absolutely, yeah. I mean, we have a lot in common. We do things differently in terms of the products we produce, but we have some very kind of core things that go throughout our the way we develop tools, how we develop tools, and the people we develop tools for. One thing that we really want to kind of talk about here is we're going to be talking a lot about the background into why we develop tooling like this, why we go about kind of some of the security aspects we do the way we do, rather than just focusing on tooling and things like that. This isn't necessarily a pitch. We will use some of the tools, Snyk and Sonar as examples to show how we have achieved what we set out to do. But we really want to kind of send that message about why we did what we did.
And probably a good thing about the timing of things a little bit, because we could have done this webinar maybe months or years ago. For Sonar Source, it's actually pretty recent to look way closer at security. For some of you that may use SonarQube since a while, for us, it all started with what we call maintainability. So technical depth, the fact that the code base is clean, that if you want to fix a bug or write a new feature, it's fun and enjoyable. It's not a nightmare of going through spaghetti code and 2 days of refactoring. And that kind of drew us for a number of years. A few years ago, we looked more closer at reliability. So reliability this time is more about bugs, for example, making sure that you don't have any faulty logic in your code. Simon and I both been devs, so I'm sure we've went through our share pains of bugs from time to time, but it's mainly kind of, there shouldn't be end user impact because of a faulty logic in your application. If you're a Java developer, you may know about null pointer exceptions, for example. This is kind of a day-to-day of developers. And at Sonar Source, it's only been roughly 2 years that we started to invest way more into security, because we came to realize, and then I can probably hand over to Simon for the background on Snyk security, but at Sonar Source, we realized that you can have a totally maintainable application, which works very well, totally proper in terms of functional use cases. But end of the day, if you still have a vulnerability that somebody can break in and steal some data, then you have a security problem. You're okay in maintainability, you're okay in reliability, but you're not okay in security. And this is kind of the theme that got us to get closer to Snyk also, and do and have those conversations with Simon.
Yeah, I agree, and I think more and more these days, in particular, security issues are seen as just just as bigger bugs, as if not bigger bugs than quality bugs or performance bugs. They're all kind of issues. They just maybe have a different label on them, typically because the more traditional siloed teams, you have that kind of expertise for security engineers and things like that. From a Snyk point of view, we started very specifically around a security kind of knowledge base. The tool we tried to create was we always say we created a developer tool rather than a security tool. Our background happens to be security, but the tool we want to create is a tool that is a developer tool, and that was kind of like one of our key things. So yeah, we started in security. We did obviously think about after the first few years, what's the next stage, and we did look at different things, as we're going to talk about with the different areas of security, whether it's SAST or SCA and things like that. But we very much wanted to stick around the SCA group, and we'll talk about that a little bit later as well. So
it's funny the way you it's funny the way you say it, because I think it kind of shows a little bit how things are evolving too, which is probably 10 years ago for code quality, people would have expected quality managers and a quality team, and you have a quality council that establish the best practices. And now it's a no-brainer that quality is a developer's responsibility, right? Developers have to write quality code. And security, we feel, and we've discovered, because us Sonar Source arrived with the developer mindset on security, and we're like, oh, but there's security team, and there's many different technologies, and there's auditors, etc. But we think there's probably the same shift happening, which is a good chunk of the security piece can be owned by the developers and can have a big impact on the developers. And Simon, I think what we want to do is kind of show a little bit that landscape of security and explain, okay, amongst everything in security, what kind of things can be addressed by developers and can be owned also by developers.
Yeah, and it's interesting you mentioned the kind of different groups as well. I mean, you've got security teams, you have developer teams, there's operations and different manager teams. I think before we actually jump into the landscape, I wonder if we want to, while we're talking about the kind of ownership of security, I'm going to launch a poll very, very quickly just to see what people's thoughts are about the ownership of security. So I'm going to launch that now. So hopefully you'll see something on your screens now. And this is basically, who owns security? Is it operations? Is it developers? Is it security? Yeah, I think this is a multi-choice, so you can pick as many as you like. Wow, the numbers are coming in right now. I don't know if you can see this on your screen, Nicolas.
Oh, yes.
You can. Excellent. So we're
My
going to
first
share
time
this.
doing polls on GoToWebinar, but I can definitely see it.
Okay, they've stopped moving a little bit now, so I'm going to close that poll, and I'm going to see if I can share these results out as well. So hopefully everyone else can see what we can see. So look at that: 9 out of the 10 people who responded, not out of the 10, but 90% of those who responded believe developers own security. So 3 out of every 4 believe security own that. Just under 2/3 think operations own that, but it very much looks like there's a joint responsibility here in terms of who does
and to
that.
me, this speaks to one of the points that we wanted to clarify in the next section is if you stay at the security level, if you stay at the, is this a security tool? Okay. And you don't look in the different kinds of security tool, then okay, security tool versus security tool versus security tool. It's one tool, who does it go to, right? And suddenly you're forced to choose in some way of, is this going to be handled by the ops, or is this going to be handled by the devs, or is this going to be handled by the security team? Whereas, starting to have, removing the complexity, sure, it's complex technologies, but the use case, everybody should be able to understand them and say, okay, this kind of use case can be handled by the development team. The security team is going to do this kind of tooling. And suddenly it becomes kind of this complementary thing. I think this is one of the reasons why we wanted to do a webinar together, is because we are complementary. It's not Snyk versus Sonar Source, it's Snyk and Sonar Source. And that's kind of the landscape that we want to go through a little bit. Did you have that image, Simon, that maybe we can share? Where we show a little bit of that landscape.
Absolutely. Let me share that right now. There we go. Okay, so you should be able to see that up on screen. There we go.
Yeah. So typically, to what we discussed, and I think Simon and I can go through those together. But once you start opening, okay, what's within security, because security starts to mean a lot of things and maybe too many things. You actually have a lot of technologies in there, SAST, SCA, DAST. Simon and I are going to clarify some of those. A lot of arguably buzzwords, almost, things like DevSecOps, InfoSec, OWASP. Screen turned blue, Simon, I'm not sure why. But many also kind of marketing aspects to this, and also some standards, some certifications. So kind of really a lot of different keywords that can be used in many different contexts, but trying to zoom a little bit can help to understand what those Ds try to fulfill, right? Typically the security of the environment we've said here is, as you deploy something in a production environment, can somebody break in that environment? One I like, for example, is security of processes, right? Is the code on my laptop encrypted? This is a security topic. Does it have to do with developers writing code? Less directly so than, for example, dependencies or the code. So Simon, I think on your side at Snyk, it's more about the security of the dependencies, for example.
Yeah, absolutely. So on the right-hand side here, of course, we've got more kind of about the kind of code, different parts of your application, which is either built in by code that you as a developer will write, or you as a developer will pull in as a dependency. So from our point of view, we're very much focused on the dependencies. So these are the third-party libraries which you'll typically pull in through your package manager if you're using something like Node or NPM, or if you're using Java and a Maven or something like that. You'll pull in that build, the part of the build process will pull in all these dependencies, and not just direct dependencies, but the transitives beyond them as well. And this can sum very, very quickly to hundreds of dependencies which your application can effectively be constructed with. And it's very important that that the dependencies that you use, you do one of two things. First of all is, of course, understand which dependencies you're using, and be able to validate that the dependencies that you grab are not just being looked after correctly and maintained at the same level at which you maintain your own code, but also are kept up to date based on as and when security vulnerabilities or bug fixes, but in our case specifically to security, known vulnerabilities are found in those packages, that you keep your versions up to the I guess either the minimum version that you require that has the fixes to vulnerabilities, or if you choose to keep up to the latest versions, you can equally do that as well.
And it's nice because, again, going back to the complementary, right? When you talk about dependencies, you're almost kind of the roots of your code, the roots of your program, all the sub dependencies and relative dependencies, etc. And when we meant highlight the security of your code, right? And we're going to come back to the technologies that support this. On the Sonar source side, it's more about, okay, your code, the logic that you've written, even for example, if the dependencies are totally safe, maybe you've at some point have introduced a vulnerability or a faulty logic into that code itself, and that's something you have to address, and so you have to have that big picture. The security of the runtime, for example, is yet again another topic where in fact you take everything as a black box, right? You take the code, the business logic that you write plus the dependencies, you execute it and you bombard this application, but that's something else. So I think Simon and I are going to more focus on those two, those dependencies and the code, talk a little bit about the technologies. And Simon, it's something we do not do at Sonar Source, but I believe what you do is called the SCA, software composition analysis. So I will let you give some more details about this.
Awesome, thank you. Yeah, so SCA, sometimes it's referred to as software composition analysis, and it's basically when we think about how your application, what your application is composed of, and understand ultimately the different modules and packages that go towards creating that application that you further then deploy into your production environment. So there's two stages really. The first is actually understanding what is composed in that application, so gaining the visibility into the open source packages that you are pulling in, both directly and, as I mentioned before, indirectly. So you may only pull in a couple of packages directly, but that might then further pull in a whole tree of dependencies, maybe tens or hundreds of dependencies beyond that. And the second part of that is analyzing the risk and assessing what kind of known security vulnerabilities that you have in your application. And this is, when we think about open source, we can think about the known vulnerabilities as well as the licenses that those packages and libraries have and are written under, because they can actually carry a risk to your code as well. They might have certain limitations on what you can do and what you need to do once you package those libraries into your project. So understanding the risk of that and actually being given information is kind of like one of the nice to haves with something like SCA. It depends on tool by tool implementer of SCA as to how much that will then give you to actually remediate and fix those. And the key thing here at the bottom that we mention is we care about the dependencies here, not the source. So as with something like SCA, when we look at the dependencies that exist in your applications, we care that it's a specific dependency at a specific version. We don't necessarily care about any of the source in the application that you write, because that's outside of the bounds of something like SCA. So
and you do look at some of the files that are in the code repo, right? So for example, the manifest or the POM files, that's where you find.
Absolutely, yeah. And there are different ways of actually doing the SCA test, and one of the ways that we do it is actually by looking at the manifest files. So by looking at the manifest files, we can test in SCA very, very early, and as a result, that we can do that, in GitHub or your SCM of choice, your code repo of choice, because we don't actually look at the source there. We look at the manifests and then build the dependency graph from those manifest files. So I'm talking your package JSONs or your POM XMLs and things like that. And the results that can give you, of course, will provide you with a dashboard. This is the UI, whereas we would normally expect developers, as we'll see a little bit later, to actually more interact with at the command line or during an IDE or as you're checking code in, but we typically, see these snapshots where you can see a number of vulnerabilities. So I'm looking at the top left here, the number of vulnerabilities that are happening through a number of different paths. On the right-hand side, you can see here we're pulling in from GitHub, so we're looking at your manifest file here, not the source code. Then on the bottom left, you can see the vulnerabilities can be categorized based on severity, and then also the ability to remediate those. So that's just an example of what an SCA kind of tool will do, and that's hopefully giving you an idea of what SCA is. So let's move over to SAST.
Yeah, absolutely. And so same objective here, which is to kind of explain, sure, it's a technology, but what is this technology mainly about, and what's the value it can add? I think it's maybe a good time to say also that Simon and I are happy to take any question as we clarify those, and if you have anything. So I think the chat is open to everybody, so feel free to throw them in, and we'll try to grab them as we go. So on the Sonar source side, when we started to look at security, we had, like I said, been having codonizers 8 years in the making, and what we know very well to do is static code analysis. And actually, static code analysis has almost a synonym in the security domain, which is static application security testing, and that's really what is SAST. And one of the key parts here, if there's only one keyword, is the static part, because it means that we are only looking at the code itself, almost like a book, right? There's the notion of scanner. You have a scanner which scans the code, is then going to obviously build an interpretation and execute some rules against it, but there's nothing happening dynamically. There's no program execution. There's no usage of the program, right? Some technologies are about you using your tool and something monitors your usage of the tool. Here, it's just about the code itself. And in fact, there is the equivalent, not the equivalent, but the counterpart, which is called DAST. And DAST is simply for Dynamic Application Security Testing, which is kind of a technical term. You may know about penetration testing. Penetration testing typically is DAST, which is you have your black box, you run your application, and then you bombard it with some data, etc. Here, the SAST is really just you have the code, and the tool is going to scan the code and run. Typically, we provide some scanners, for example, as part of the pipeline, and as part of the pipeline, we're going to execute the code scanning. So I think it's really, again, it's different technologies, but the point is it's complementary technologies, which turns into complementary products, which altogether can help kind of having a more secure application. Simon showed what it looks on the Snyk side. On the SAST, on the Sonar source side, you're going to see your code, obviously, because it's about the security of your code, right? So in the tool itself, you will find the code like you're used to see it. Only the tool is going to highlight some pieces saying, well, you actually have a vulnerability there, or you have a problematic flow where you can have malicious data. We'll have a demo later on. And typical also expectation of this kind of tool is that it gives you kind of a higher overview, right? So across your code base, how are you doing? Also in terms of maintainability and reliability in our case, but now we've extended that to security. And also because this can help create a user experience, right? Finding the issue is not enough. At some point, you need a user experience, which we'll talk about, to understand really what's happening in the code that you're developing and where should you focus for remediations. And yeah, I think we can remove the screen share at this point. One of the things we wanted to highlight, we mentioned it earlier as we started the webinar, is that there's many things different here. The technologies are different, the products are different, the speakers are different and are not in the same place even. But the point is, now we want to focus a little bit about what's common behind all this. Why are Simon and myself kind of speaking with this with the same energy and the same excitement, which is we think we're trying to do things in a similar way. We're trying to do things for developers first, because we have a belief, arguably, but we're pretty much convinced in this, that providing value to developers first is going to enable them to have a pretty strong impact, and then kind of grow additional benefits to organizations, to multiple teams. We'll talk about this. But what we want to focus on a little bit now is, what does it really mean to be focusing on developers? Which I think, Simon, in your case, it's the same thing, 3 years, right? Since you've launched Snyk, it was like, okay, we're going to provide tooling for developers.
Yeah, I mean, the way if you look at something like with the movement of DevOps, the way code is constantly being pushed every single day, every single week, or a few times a day sometimes, it's very very hard to use the more traditional mechanism of security audits and big gaps between our security testings, and that's why when you look at some tools like DAST, for example, some areas of security testing, other mechanisms of security testing to come around, like IAST, because they're shorter running ways of doing a similar thing. And one of the things that we need to do, in my opinion, is to enable the developer. And it's the only way you can actually scale this kind of DevOps methodology, whereby if you want to continually push to production every however many minutes or days, you need to be able to enable the developer, because it's the developer that scales that. Typically you see 100 developers, 10 operations people, 1 security person, and that just doesn't scale. You can't outsource, you can't third party the security there. It has to be a part of what the developer is doing in their daily role to be able to actually do that. So developer first is a must here.
And maybe before we go and show that in practice, I thought we could run that second poll we had now that we clarified the technologies. Plus, we have tons of people here today, so we'll be able to get some good data. You have control, so can you kind of recap the second poll, Simon?
Absolutely. So we've talked about the different security practices, and I'll just go through a few now. So there's SCA, which is very similar to what I described with the ability. In fact, let me just launch this poll, and I'll talk about it as we go through. So what security practices are you using today? SCA, software composition architecture, the ability to, when you compose your application, you're looking at testing the dependencies. SAST is the static testing of your source code. DAST is the dynamic testing, whereby like very similar to what Nicolas was saying, with more of a kind of penetration style, longer running. What do we have? We have RASP, which is a kind of like a runtime application security testing. And IAST as well, which is a very lightweight version of DAST, which is kind of like an async version of DAST. So we'll see how that goes. And it looks like Nicolas, we're doing pretty well here, right?
Yep. So it's good because SCA and SAS seems to be on the top, so it's exactly what we wanted to talk about.
Absolutely. So let's share these results, and I guess that's probably not too unusual, given that those are that's what we're going to be talking about. So I guess people who are here and attending are probably going to have more of an interest in these areas. So very highly DAST as well, which is good.
Yeah, and I think it's a good transition. We've talked about developer first, and kind of shown how SCA and SAST have this ability, by the nature of the technology. If you only look at the code, if you only look at manifest files, you are able to be developer first and to really kind of, some would say, shift left. So I would say yet another potentially buzzword, but shift left is really about providing value. Well, I will start with what shift left is really. It's about, you shift all your testing to the left, right? So the earlier you test, the earlier you detect bugs and vulnerabilities, the better shape your application is in. I think what Simon and I are going to illustrate is you actually have to care about who's on the left. On the left is the developer, and you can't throw any kind of tooling to the developer, right? The developer have certain expectations. They have, certain values that they care about when they code and when they do code review. And to us, I think to Simon and I, to Snyk and to Sonar Source, what being developer first means is really about fitting into the code review process. I'm going to take control here. All right. Can you pass me the ball, Simon? I think it will be
absolutely.
Fitting into the code review process. So basically, up.
There we go.
Perfect. Almost there. Sorry about this. Okay, so as we now talked about the technologies and trying to be developer first, to us that really means providing feedback during the code review process. And we're going to talk about, where is the best place for that. You probably have some ideas already about this. What we wanted to share is really what are the typical developers' expectations. Here I've marked this as Sonar Source learnings because we fit into code review for years. It's probably the same on the Snyk side. This is, as much as you want to fit into the code review process and provide early feedback, it can really go wrong, right? If you have a tool which is not quick enough, for example, or not performant enough, this is going to take time. The developer is going to switch to something else, and you will lose this opportunity to provide the feedback at the right time. This idea of having actionable feedback, right? The action should be clear. It shouldn't be on the developer to figure out, okay, so what am I supposed to do with this? And for example, the worst of this kind could be a false positive, because a false positive is the tool saying the developer, you have to take an action, when in fact it's more of the tool being wrong. So there's some things that, you know, every tool and everybody has to be quite careful with. And on the other side, it can go very well, you know, if the feedback is fast enough and prevents any context switching. It's sufficiently localized that the developer is like, oh, okay, this is about the piece of code that was just written. Now I can go and discuss this with my peers. And really, we think it's also an opportunity to learn, because it's not about the tool which gives an opportunity to learn, which is it's more about the code review itself is a process. And I think, Simon, you can back me up. You've been a developer before myself, but the act of doing a pull request, the act of doing a code review is really all about asking feedback about the code, right?
Absolutely, yeah. It's validation, and almost, you know, it's like the value of open source, right? The value of open source is to try and get as many eyes as possible. The value of a pull request and being able to get kind of code reviews on those kind of pull requests is, you know, before I commit this change, before I push this change into the flow, let's get eyes on that, and let's actually get as many tests as we can running on that to police that the code does live up to the standards which the team has requested that it does.
Yeah, and we can probably go ahead with the first demos. I'll go ahead and kick it off. So the first area of focus we wanted to talk about is really this notion of accurate and actionable feedback. This one is more going to be a more lightweight demo of when you have a SaaS tool, typically the way it lives, and this is SonarCube right here, is you have a number of rules across a certain number of languages. SonarCube supports multiple languages. And then you can, for example, filter those rules to vulnerability rules. And the way we think of this is, to us, this is the data, right? A certain tool is going to use a set of data to provide feedback. And that data has to be quite, first of all, up to date and accurate, because that will in turn drive the feedback that's given to the developer. One example here is, you know, as we implement those rules, the notion of false positives, I've mentioned, it's typically something that, you know, we really have to be on top of, because false positive is something that can undermine and kill the entire value proposition of a tool that says we're friendly for developers. But then if triage needs to happen, or if the issues are not clear, this is no good basically for developer adoption. So without going directly into how the feedback is given to the developer, what we do on the Sonar source side, and Simon mentioned something pretty important, is the open source foundations, right? Having open communities, having open source product, we think is pretty powerful in that respect, because suddenly everybody can share feedback about the rules, can help mature them over time. I think it would be completely unreasonable to say we have no false positives. This would be lying, basically. There's always going to be a small pieces of false positives here and there, and really the core value is about, okay, how do you gather that feedback? How do you act upon that feedback about false positives? In our case, we have this Sonar source community forum, and you see anybody can come and report a false positives, share a code example, and I can tell you we have a language team at Sonar source. Their first mission is going to be like, heck, we got to fix this quick, because this is no good. And basically kind of driving some community awareness and community maturing the rule altogether, so that we kind of have things even sharper over time. And I think on your side, Simon, I will stop the sharing. It ties back a little bit to the database that you use, right?
Absolutely. So there's a couple of bits that I want to talk about here as well. One is the oops, can you see my screen?
Yep.
You can. Excellent. So one is the database that we use, and very similarly with false positives, it's you know, the user experience on a developer using a tool is all about not just when it works, but what happens when it doesn't work. And one of those things is false positives. And for us, reducing the false positives is about getting the best data feed we can possibly get. And for us, that's the database. So here, for example, the database that we have, and you can go to snyk.io/vuln, and you can see our full database here. So if I was to do a search, currently we're just searching anything, but you can see all the different package names and ecosystems that we have. If I was just to let's go to Lodash, for example, and grab the latest Lodash one. What we do is for every vulnerability that comes in, whether it's a public vulnerability in a CVE or a vulnerability which we have found, we have researched, we have found that exists, we will make sure that enough information is added into that vulnerability description as well, including a whole bunch of information about what the vulnerability is, the types of attacks, and the vulnerable versions that the Lodash or the vulnerability can exist. And we also provide more information in the CVSS scores so people can triage. But this information is extremely important to help developers understand what that issue is. And yeah, as I mentioned, we care very, very much about the false positives as well, and our security team which is distributed between London and Tel Aviv, will hand touch every vulnerability that comes into our database, and we will continually make sure that we reduce and keep the bar very, very high for good, solid vulnerability information and versioning information to make sure that there are no or reduced false positives. One other thing that I wanted to describe here as well is the information providing with information that will allow someone to then go ahead and remediate. So for example, I have scanned an application here. In this case, I've pulled it in from GitHub. I've scanned this application and it provides me with a number of vulnerabilities. So here we can see there are 39 vulnerabilities. If I take one here, like a directory traversal in the ST module, what we can see here is the information that we're given, very specific to our application here and how we're using this dependency. We can see it's introduced by a certain version of this library, which is ST version 024, and the remediation, the information we're giving here is very actionable. The remediation is to remove to the minimum version you need to fix that vulnerability, which in this case is 025. So it's the combination of having solid information as our data, which is equally reducing the false positives, and then giving the information so that developers or whoever is going to be looking at this has that next step to actually know what to do next.
I think we have in the Geneva office, actually, we have this kind of motto written on the walls that says the right data at the right place to the right person. And to me, it speaks to the combo that you want to make sure you're nailing so that, people can really take actions from the feedback that the tool is giving back. On the SonarCube side, at SonarSource, and actually, so first of all, you can tell Simon is a better presenter than I am because he's sort of showing the website with the database. So on our side, rules.sonarsource.com, for example, the data I've shown, which is in the product, also is on this website. So a pretty cool resource to share with any developer, showing kind of what are the rules that we offer to the development communities. So this data gets turned into automated rules. And to us and to Snyk also, Simon showed it, the right place really is, the pull request, which is kind of really where the code review happens. I've picked a GitHub example, have the same concept in Bitbucket, in GitLab, in Azure DevOps. And at this point, the developer is really doing this act of opening up to the team and saying, hey guys, can you share some feedback about this? And those tools themselves, those ALMs, they offer APIs and means for external tools to provide feedback. And so that's exactly where we fit with task typically in the pipeline, SonarCube code analysis, that's going to look at the pull request and kind of analyze it against a set of conditions, against the rules that are activated, and come back to the developer with, I've checked your pull request and it's all good. Or in this case, there's a number of things that you have to keep an eye on. And obviously here it's just a number, but at this point, you can simply go, in the tool and understands what are the issue. And in that case, you see you have the code right here. It's telling you, well, here, this is Java code. You're generating a cryptographic key of 512 bits. The world knows how to crack those keys. And it's not just a matter of raising the issue. It's then a matter of, providing, exactly as Simon was showing, in terms of vulnerabilities and packages, the reasoning for why did the tool raise an issue, what should you care about from now on, what should you look at, how's a good way to fix it, what are references that you can have a look at. So this is one example of providing, giving the feedback, letting the developer dig into that feedback, understand where the issue comes from. And you might notice here we have this thing called security hotspots, which is a bit unique to the way we went into security and maybe the way we went as a SAST tool, which is we realized that we couldn't call every single vulnerability. That would be pretty much deceiving towards the developer. Vulnerability is a strong statement. Sometimes there's something to review. And I want to give an example of that. For example, and you can see the color code is different here with the blue kind of issue. It's saying, make sure that this cookie is used safely. You can't flag this a vulnerability. If you tell a developer that using a cookie is a vulnerability, Simon, if I tell you this, I think you're going to tell me, what the heck, right? However, if we tell them, look, you have to be careful because using a cookie can lead to some vulnerability in some cases, which is if you put any sensitive information inside the cookie, you can be sure that you may have some vulnerability problem at some point. So again, some guiding information for the developer to review it with his peers, which is the perfect point in time because he's doing a code review in his pull request and can then triage the issue. So this difference between, so that was a security hotspot. The difference between a security vulnerability and a security hotspot shown directly within the pull request. And I think that's kind of shows, us with Simon really wanting to bring the right level of feedback at the right point in time during the pull request.
Mm-hmm. Mm-hmm.
The last piece we wanted to talk about, I think, Simon, you've touched it a little bit. So maybe what I can do is keep it from there.
Sorry? Yeah, I just wanted to show a little. So did you? I just wanted to show a little bit about triaging as well.
Go ahead.
Yeah, so I wanted to just to jump in and show my screen. One of the interesting things about triaging that we can do is, and this is really about kind of making when a developer comes in and wants to understand what they can fix. It's about understanding, boiling things up to the top and saying, what are the most important things to fix now? If I have 10 minutes, an hour, 2 hours, what can I fix today? What are my biggest pain points? And there's a couple of ways of doing this, of course. What I showed previously was the full list of vulnerabilities, and this is in a specific application or a project. And it's key to be able to look at the severity, and the severity is very heavily based on the CVSS score. So, for example, here we have 15 highs, and I can just say if I wanted to only look at the highs, or I can say we're looking at a there we go. If I was to remove the filter, I can say only show me those highs, or I want to only see the mediums, or whatever you choose. And when I click on one of these to see more information about this issue, you'll see that it has a CVSS score, and the CVSS score provides information about this vulnerability and about things like what the attack vector is, what the attack complexity is, and the answers to each of these will provide us with a score that'll give us a severity, and it'll tell us how at risk we are by this kind of vulnerability. One of the other things is, of course, looking at the top-down view to understand which areas we want to focus on first in our application, and this could be based on project. We can look at it per dependency or per issue, and a whole bunch of other things like that.
And to me, one thing that is cool in what you show is, well, there's the use case, there's the user flow, but there's also simple things such as the UI and the UX, right? Which is suddenly we're not talking about rules and database like we were talking 10 minutes ago, which is the roots of things, super important. Yes. But we're starting to go at product level, which is, if you just provide raw reports or raw data to developers, some of them are going to like it. Some of them value at some point, a nice user experience that's going to guide them and to really help them understand the issue. I'm going to show a similar concept in Sonar Cube. So basically now, throughout the demos, we've been from, the data, the database, accuracy, making sure we don't have false positive at the right place in the pull request. And now, to me, what Simon showed, and which is kind of wrapping it up all together, is the user experience, right? So if we take back Sonar Cube, again, those reliability, security, maintainability, but we're here to talk about security today. In this case, the list of security issues, you can find the cryptographic issue that I mentioned earlier on. And an interesting one is this one, refactor this code to not construct OS command from tainted user controlled data. And in fact, instead of showing you the issue directly, I'm going to try to do something here. I have a fake screenshot of that issue that I find pretty interesting. So this is an actual issue in Java code on line number 17 on that second file right here. It's essentially saying that runtime exec command is executing an OS command from user input, which is great, right? You have found a vulnerability. Well, it's not great, but the tool telling you that is really great in the sense that, oh, I finally caught a vulnerability. However, the next step, and I can tell you, I speak of experience, that when the dev team sees that, all the dev team wants to do is to fix it. And the first thing you have to do to fix it is to understand it. And in that case, not sure how many developers are in the audience, but even as a developer, it can be a pretty daunting task because you have to figure out how is this command built, which variables is it using, which input is it based on, and you have to figure that out yourself, right? And if that's all the UI you have, then maybe you actually do need a security expert or a security team. And us at Sonar Source, at least we don't. And we have the thing which we dog food our products, right? So we use our products on our own products, and we realized, gosh, if developers want to understand this and take an action, we have to provide more data for them to kind of understand the issue. And so this is the actual UX. You can see a little bit more highlighting here, and this kind of code locations on the left, where it's almost like a story, I find, right? We start from here, so point number one, say, well, you get some user input in this HTTP request, and you put this in the variable, can even navigate with some shortcuts. You decode it, and you make a cross-file function call, and you build your command, and you're executing your command. And so to exactly the same point, right? It's a different UX than the one Simon showed, a different objective here, but the intent really is the same, is building a UX that is going to help the developers understand the security issue, again, with some pretty solid documentation to even go into more details. But because once you understand it, you can take an action, you can fix it. And the whole thing of developer first becomes a kind of reality, and developers have all the tools and all of the data and the explanation at their disposal to fix the vulnerability. Right, so I hope the UX was cool to you also, Simon.
Yeah, no, it looks awesome. I love that usability, and I think it's great that it came out of a lot of it came out of the kind of dog fooding, which is something that is very important that we do as well. In fact, is we have the Snyk team. We have the Snyk team dog fooding Snyk as well, so we test Snyk with Snyk, which is super cool as well. And we actually have a question. Let me just double check. It's a question from Jonathan Irvine saying, if you click fix this vulnerability, what happens? Will it update your package? Well, actually, that's my next demo, and my next demo I was going to show you here is with this example. The question is, what happens if I click fix this vulnerability? And this is all about that, not just providing the remediation advice, because that's just half the story, which is a very important leap, actually, rather than just saying, here's the problem. But the question is, how do I actually then go about and do that? So if I do click fix this vulnerability, we'll see what happens. And what it does is it quickly runs that test again, just to make sure, obviously, that the vulnerability is still there and that's all still cool. And what this is going to do is it provides me with a full list of the vulnerabilities with the issue that we want to fix. And if I go to the bottom and click open a fix PR, because I tested this against a GitHub, what this is going to do is going to do one of two things. It's either going to bump me up a version of my dependency so that it pulls me up to the minimum fix required to eliminate that vulnerability, but no higher, because we don't want to potentially cause any other issues. But equally, if that doesn't exist, sometimes we have a Snyk patched version, which allows us to do a binary overlay of just a certain backported few line fix. And if I come back here, we can see the fix here is just to update our package JSON from 024 to 025. And one other key thing which allows us to be able to, kind of do this throughout our pipeline, is have this integration at all stages of the pipeline. So, we've just shown you a few places, but of course you can run this test during IDE, during CLI, during every pull request as well. And you'll notice that even this pull request, which we automatically created there, gets automatically tested for both license issues and security issues. And we check the delta in that pull request to make sure that we're not introducing any new vulnerabilities. And then further on, if you want to use in CI or even monitoring in production, we can easily scan exactly what you're running and be able to provide you with automated pull requests if new vulnerabilities or new fixes become available. So it's that not just giving you the information, but providing the developer with a really actionable one-click, or in some cases zero-click with our monitoring ability to fix those vulnerabilities when they exist. We've only got a couple of minutes left, and
yeah,
I wonder.
I think I can. We can start wrapping it up. I saw a question. It's a good point of looking at the question. First, we have the best question asker, which is Peter Varga, saying they already use and love both Snyk and Sonar. So thank you very much. But he also asked, do we have any recommendation for RASP and IAST? At least from my perspective, I'm like, I can't answer this question, because now that we've clarified a little bit, that what we're driven by and what we're focused on would be too easy for me to say, oh, these are all security tools. I'm like, no, we do SAST. That's what we know how to do best. And I know Snyk is a great SCA tool. That's all I can say.
I would say for IAST, there's a new little startup called Detectify that do some interesting tooling in that kind of area. So do check them out as well. They've got a really nice kind of UI and UX for that as well.
And one thing I want to show, kind of to close on the developer first point, I think we showed the pull request, we've shown all of the UX we're building to help developers to have an impact. Something Snyk and Sonar also share is the IDE integration, whether it's IntelliJ, Eclipse, VS Code, Visual Studio, many other IDEs. But here's a similar example actually as the one previously, right? So the same cryptographic key with a key which is not strong enough, and this is Sonarlint saying right directly in the IDE as you code the issue there. And this is really happening as the developer types. Instead of analyzing the whole project, it's only analyzing the current file. And I think it speaks to the objective of any kind of feedback that we can provide as early as possible. Bring it even there. We have this motto for Sonarlint, which is kind of fix issues before they exist. It's kind of because at this point, the issue was not even committed in the code base or in any pull request, and the developer gets a chance to either fix it, but sometimes just learn about it and understand, okay, what's the best practice that I have to be careful about, right? And I think you have the same concept on the Snyk side, Simon, to provide, some of the feedback, at least during the IDE usage directly.
Yeah, no, absolutely. It's a key area to be able to exist in, because obviously it provides the user with the most immediate feedback. And in fact, let me quickly, I can just quickly show my screen. So I'm actually using IntelliJ as well, and obviously the dark format, because why not? But what I'm going to show you here is obviously this is a Snyk scan on the right hand side here for one of my specific Maven projects. So if I scroll through, find a vulnerability that I want to fix, you can see that the suggested upgrade would be 2330. I can literally just click on that, and it'll take me right down to the place that I need to change with my suggested upgrade as well. And of course, I can, if I wanted to, click through that and actually update this version from 0320 to 0329. So that's nice and easy, and it gives you that ability to update directly as well. We've got a couple of minutes left, and I want to make sure that we get through a couple more questions. One of the questions that has come in from Sean is, I'm assuming that Sonar and Snyk integrate together as well. Can you confirm? So I mean, yeah, right now we're kind of just working together. It's different stages, right? So one of the nice ways that you can kind of integrate with us in that respect is grabbing data from us and being able to put us into a single dashboard. That kind of thing would be nice, just from grabbing kind of data and pulling us into the one panel. Another question from
Sorry, Simon, I was muted. I just want to comment on this one. I think it's some of the discussions we've had of would it make sense to have some of the SonarCube data in Snyk or vice versa. And I think a nice way to take this question is also think about really the best place where we're providing the feedback is in the pull request. And sure, the tools may be separate and maybe they don't couple within each other, but if all your developers are consuming is the pull request, from their perspective, it's all integrated within the pull request environment, and they get the feedback from Snyk the same way they get the feedback from Sonar, the same way they get the feedback from some other tool. And right now, I think the integration we're trying to maximize and maximize the value within is really this within the pull request, within the code review process.
Yeah, so it's more important that we integrate with those existing developer tools, and then we can both exist together in the same place. And that's an interesting question from Sean as well about, is SCA part of Sonar? So that one's to you, Nicolas.
And the answer is no. So Sonar is really a SaaS tool, static code analysis. So our focus really is in the code repository that you own, that your development teams are writing. And they want to check it for, like I said earlier, on maintainability, reliability, and now also security. And as far as even SaaS goes, we're really focusing on that for now. We have it for Java, C#, and PHP. We have a long way to go to cover more languages, to add more rules, to iterate, right? We're kind of in a continuous iteration mode all the time at SonarSource. So our journey is focused on SaaS for the time being.
Awesome. And I think we'll wrap up there. So thank you very, very much to everyone who's answered the questions, and I'll pass back over to Sarah.
Oh, I'll just say thank you too. I think it was a cool discussion. I think we talked about a lot about developers. Obviously, we don't have the profiles of the people in the audience today. Probably there's some developers, maybe also some security experts, some managers, some team leads. I think one of the points also that could be worth another hour conversation is, focusing on the impact from the developers is not just for the sake of the developers, is at some point going to shine through the entire organization, because there's more focus, there's more ownership, the pipeline has a clearer structure, with the ops kind of focusing on ops, security still providing very good value on some higher level and distinct security topics. So really today we wanted to kind of stress out the developer first part and how we're both trying to focus on developers. So indeed, thank you everyone. Thank you, Simon. And let's hand it over to Sarah.
Great, thank you both. And just wanted to point out there'll be a short survey that is sent out immediately following this. So please give us your feedback. And if you want to reach Simon or Nicolas on Twitter, if you have further comments or questions, I'm sure they're happy to continue the conversation. It's at Nico Allgood, NICOALLGOOD, and at SJ Maple. So thank you everyone, and look for the recording as well. Take care.
Thank you.
Thank you.